Today we're diving into a real paradox, something that sounds kind of impossible. What happens when the driest places on Earth suddenly get soaked? We're going to explore the incredible science behind the world's drylands, from the giant forces that create them to the epic floods that can completely overwhelm them. So, let's get into it.
It's a question that feels more and more urgent. We're all seeing these wild headlines about crazy rainfall in places like the Sahara, and it just messes with our whole idea of what a desert even is. It really forces us to take a much closer look at these huge, complicated environments.
And this just nails the feeling, right? This comment from a recent online chat about rain in the Sahara, it taps into this collective anxiety we all have. It feels like the rules of the game are changing, and something that used to be a super rare event, well, it might just be the new normal.
Okay, so to really get what's going on, we have to start by busting a huge myth. The idea that deserts are just empty, nothing but sand and rock. The reality is so much more complex, and honestly, so much more vital to all of us.
Yeah, these are absolutely not wastelands. The term drylands actually covers a massive 41% of the Earth's land surface. And get this, they support 2 billion people. That's nearly 1 out of every 3 human beings on the planet. These places are dynamic, they're fragile, and they are absolutely essential.
So what makes a desert in the first place? It's not just that it doesn't rain much, it's the result of these enormous planetary-scale forces at work. Let's break down the basic recipe for how you cook up a dryland.
It really all boils down to 2 main ingredients. First, you've got this huge global system of air circulation going on. And the second one is more of a local thing. It's all about how mountains can literally shape the weather around them. Okay, so this is the big one, the Hadley cell. The super intense sun at the equator heats up the air, which makes it rise. As it rises, it dumps all its moisture as rain over the tropics. But then, this now super dry air travels out towards the poles, cools off, and sinks back down to Earth around 30 degrees latitude. And that column of sinking, dry air is what creates the world's biggest desert belts, like the Sahara and the Gobi.
And here's that second ingredient in action. Picture this. Moist air blows in from the ocean and smacks into a mountain range. It has nowhere to go but up. As it climbs, it cools down and drops all of its water as rain or snow on that one side. By the time the air makes it over the peak, it's been completely wrung out. It's totally dry. And that creates a rain shadow desert on the other side. A perfect example is the Sierra Nevada mountains in California, creating the Mojave Desert.
So, we know deserts are defined by being dry. But what happens when that dryness is suddenly violently interrupted by a massive downpour? Well, the results are dramatic and incredibly powerful.
I just love this description from someone who actually saw one of these storms up close. It just perfectly captures how surreal it is. See, unlike the storms we're used to that move along a front, these things are often super local. They build up and just hang there in one spot, fueled by the intense heat blasting up from the desert floor. And you have to remember the sheer scale we are talking about here. Over 40% of all land on Earth is considered dry land. This means these intense, localized storms aren't just a weird quirk. They're a global phenomenon, shaping ecosystems from the American Southwest all the way to Central Asia through this constant cycle of scarcity and intensity.
And that intensity can be unbelievably destructive. Think about it. The ground in the desert is often baked hard, almost like concrete, so it can't absorb a sudden downpour. All that water just runs off, funneling into canyons and turning into these terrifying flash floods. It's not just water. It's a moving wall of debris that can literally reshape the landscape in a matter of minutes.
But these local storms, they don't just happen in a vacuum. Nope. Their frequency, their intensity, a lot of that is being influenced by these massive climate patterns, almost like global puppet masters pulling the strings. And the most important one is the El Niño Southern Oscillation, or ENSO for short.
So, ENSO is basically this cycle of the Eastern Pacific Ocean getting warmer and cooler, and it messes with weather all over the world. During its warm phase, El Niño, you get things like heavy rain in South America and terrible drought in Australia. Then, during the cool phase, La Niña, the whole pattern flips. It can bring drought to East Africa and much wetter weather to places like Southern Africa. These are huge, global connections with very real, very local consequences.
And look, as this timeline shows, this isn't some ancient history textbook stuff. We've seen powerful La Niña events happening again and again in just the last few decades, including a really rare triple-dip La Niña that just wrapped up in 2023. Understanding these repeating cycles is so important because they're a massive engine driving weather extremes all over the planet.
And this is where we get to the core of the issue. That delicate balance that exists in these dryland ecosystems, it's under threat, it's unraveling. And it's not just from natural climate cycles. It's from a process that we call desertification.
Now here is the crucial point. Desertification is not about existing deserts naturally getting bigger. That's a huge misconception. It's about productive land within these dryland areas becoming degraded, losing its fertility and losing its ability to support life. And it's a process driven by a mix of climate shifts and, really importantly, human activity.
And here are the main things causing it. You've got human pressures, like farming the same land too intensely, which just exhausts the soil, or overgrazing, where animals eat all the vegetation that holds the soil in place. Then there's deforestation and poorly managed irrigation that can literally make the ground too salty to grow anything. Add in natural climate swings like drought, and you've got the perfect recipe for degradation.
So remember those 2 billion people living in drylands? Well, here's the truly staggering part. 1.5 billion of them depend directly on land that is actively degrading right now. And the UN estimates that within the next 10 years, 50 million people could be forced to move, becoming climate refugees, simply because their land can no longer support them.
And this isn't just an abstract problem for the future. You can see it on a map today. If you look at a country like Senegal, you can see this patchwork of land being damaged by everything from wind erosion to chemical degradation. It's happening right now. But, and this is a really big but, the story doesn't end there with doom and gloom. The situation is serious for sure, but it is not hopeless. All around the world, there are communities finding brilliant, innovative ways to fight back and restore the health of their land. The UN has actually laid out a really clear path forward, and it's not about some single magic bullet. It's a whole strategy that combines smart, sustainable land use with education, better government policies, targeted funding, and, this is maybe the most important part, getting local communities deeply involved in the whole process.
And we have proof that this stuff works. Real proof. In Syria, for example, communities brought back a simple, traditional practice, rotating where their animals graze. The result? They reported up to a 10-fold increase in how productive the land was. It just goes to show you that restoration is absolutely possible, and the benefits can be enormous.
Which brings us right back to the central question. Drylands are not wastelands. They are home and they are the source of livelihood for a third of all people on this planet. We've seen the forces that shape them, the threats that are unraveling them, and the real hope that lies in restoration. The science is clear, the solutions exist. The only question left is whether we can act in time to restore that balance.